Debbie very kindly said that we need no introduction, but I will actually take a little bit of time to introduce the Michael J. Fox Foundation for Parkinson's Research. And I always like to start with a quote from our founder, who was the actor Michael J. Fox. He says, "Our challenges don't define us, our actions do." And thank you. And it's funny. I specifically chose this quote because when I was talking to Debbie and we were talking about TikTok for Parkinson's, this quote rang true. And also, when I think about people who come out in the middle of the day to educate themselves, that is such a positive action of how we can strengthen each other, our loved ones, the community. So that's a very positive action that we could take today. So I definitely want to keep this specific quote in mind as we go through our presentation, because I think a lot of us are dealing with the challenges of this community. So, I wanted to tell you a little bit about the Michael J. Fox Foundation. Our mission is to find a cure for Parkinson's disease through an aggressively funded research agenda and to ensuring the development of improved therapies for those living with Parkinson's today. So, our goal is ultimately to find a cure for Parkinson's disease, but in the meantime, we're going to work on making the lives of those living with Parkinson's disease as easy as possible. So often I'm asked about the foundation itself. We were founded in the year 2000 by the actor Michael J. Fox. He was diagnosed with young onset Parkinson's disease when he was only 29 years old. And he was told, "You have 10 years left. Work as much as you can. You have 10 years left." We all know he is 57 years old right now. He is still working. He is still a working actor, and you can see him on television shows. But he decided to take his challenge and have his actions matter. So he created this research foundation. We are very proud of our track record in terms of funding. Debbie mentioned we try and mitigate as many assets as we can because we plan to go out of business. We always joke we're in business to go out of business. So we have one central office and we have people like me who travel around from one location to keep our costs down. We do not have an endowment. We don't hold on to money. Any money that comes in is usually out the door within about 6 months. So since inception, about 88 cents per dollar goes directly to research. We worked for other places. In general, that average is usually like 66 cents per dollar. This year is a big year for us. We are on track to raise about $100 million, which will officially put us over the mark for $1 billion in fundraising and Parkinson's research. So let's hope that all goes well through the end of the year. It looks like we're in good shape for that. But we have raised well over $900 million going directly to research. Over $100 million in 2018 alone, which thus far was our record year for fundraising. We have over 700 active grants at any given time. So that means we are not focusing on one area. 700 grants means we're looking for the cure in a lot of different ways, and I'm going to take a deeper dive. And also, I just wanted to point out here, there's quite a bit of research going on right here in Israel. I was very blessed to see it, and I'll share some of those findings as we come along. I was at Tel Aviv Medical Center earlier this week, so I've learned quite a bit about what's going on in our own neighborhood, so hopefully I'll be able to personalize some of the information for us. But over $17.5 million since the year 2000 has been spent in the land of Israel, which I think is quite impressive. But Michael says he doesn't care where the cure comes from, and actually a third of our funding is outside of the United States. So we are very glad to fund any good idea. We don't care where it comes from. And it seems like a lot of good ideas are coming from right here in your homeland. So, another question that I get asked is, who decides what to fund? how do you decide, out of all of these grant applications, how do you decide what's promising? So a little context will help us further down the road with that as well. So we actually have a research team. It's grown a little bit since I made this slide, but includes at least 11 right now. It's I think 12 or 13 PhDs. So those are the people who are really who know the science and who are living and breathing Parkinson's research. We also have an MD on staff. She's a movement disorder specialist. And we want to make sure whatever we're funding, we always have an eye on the patients. So we wanted to make sure to have a clinician who's involved in this process of deciding what to fund. And then in addition to that, we have a group of business strategists. And that's simply because we want to be smart about where we put our money. You could have the best idea in the world, but if your budget isn't good, if you don't have an infrastructure that could help carry out this wonderful idea, then we don't want to invest with you. We need to invest with things that are viable, really are set up for viability in terms of finding a cure. So this is our research team, and they're the ones who make the decisions on what we fund. And they also are always keeping an eye on the pulse of where we think the cure will come from. Another piece of information, this is a little bit US centric, but it actually does apply here as well, is I wanted to just walk through drug development because I think that will also help us when we discuss our symptomatic portfolio. So when we talk about drug development, and most people who have Parkinson's disease will be taking drugs, it's quite a long process. Anything that we have in our medicine cabinets, even if it's not, Parkinson's medication, it usually takes at minimum 10 years to get there. There's quite a lot of procedure involved. So just to walk through those steps, when a researcher has an idea or a scientist has an idea and it lives in their head and they want to test it out, they apply for something called seed funding. So that's initial funding where they're getting money in the US government. It's usually from the NIH, the National Institute of Health. Here it's wherever it might be. And then they'll get money to run, to test their experiment, usually for about 3 to 5 years. And at that point, they're hoping to have results that support their hypothesis. And they're hoping that those results are deemed good enough for industry to invest with them. And industry means like a very big pharmaceutical company or a biotech company, perhaps a venture capitalist. And what can happen sometimes is somebody can have a great idea, they get their seed funding, and maybe, when you're really hashing things out in your original model, the results that you produce, even if it is a good idea, is just too risky for a company to come in and decide to invest about $1 billion in, because that's how much it costs for a drug to get through to where it needs to be to get through clinical trials. So in research parlance, this is sometimes referred to as like the valley of death for research. So there could be like these excellent ideas, but maybe, they found something out in year 3 and, there just wasn't enough time and money for them to continue to, explore that idea. And nobody wants to invest with them because it's just deemed too risky. So the Michal J. Fox Foundation has found that that's like a really great place to call ideas. You have enough initial information and initial results to really, see if there's promise there. But, we don't have $1 billion to invest with every one person. So what we'll do is we'll accept grant applications that have some data that's coming in, but maybe need, a little bit more to de-risk their idea to get in a big industry partner. So we'll help companies at that juncture, and that's where we invest so that we can really push our money so that it's utilized in the best way possible. And in addition to that, we'll help the companies that we support because we have created relationships with industry partners. So when they invest with us, or when we're investing with a company, we can help them out in a myriad of ways. So we can help them with their trial design, and we can also help them pair up with partners who really have that money, like a big pharmaceutical company, that they need to get into your, medicine cabinet at some point or whatever else it may be. So I also kind of want to walk you through the stages of clinical trials. Very often I'll get sent articles and people will ask me about a trial and I'll see there's like a little picture of a mouse at the top. If something's being tested on animals, that means that it's preclinical, which means there is at least 10 years until we have like real results that we can use with humans. But when you hear something's in a clinical trial, either phase 1, phase 2, phase 3, that means it's being tested on humans. And it's something that we can really look forward to seeing actual results from in a manner that we can measure in real time. So, 6, 7 years. So we're very excited about things that we see in clinical trial because that means we can expect results more quickly.
The trials were all around the world?
So yeah, the trials are all around the world, including here in Israel. And we're going to explore that a little bit more as I go on. So now that I kind of give you a background on the organization and how we fund what we fund, I wanted to get more into the actual research because I know that's what you're here for. And so let's get into our research update. Now, the way that we decide what our research priorities are is, like, in general, they fall into 3 main categories. Our first category is something called disease modification. And when I talk about disease modification, that is something that will stop or slow the disease. And that's kind of what I look at as our cure portfolio. That's where we invest money in finding a cure. And we explore many different ways, many different paths to a cure. But we'll explore some genetic targets like the LRRK2 or LRRK2 or the GBA gene, which I find a lot of people in our community have, or alpha-synuclein. We'll remember some of these phrases because we're going to come back to them in a minute. Our second portfolio is the symptomatic portfolio, and that's really where we concentrate on the day-to-day symptoms that people have and how we can help the symptoms of people with Parkinson's disease. And as we know, everybody's Parkinson's disease looks a little bit different, so we will focus on motor symptoms, non-motor symptoms, and we've also noticed some emerging targets, which we'll get to in a bit as well. And then our third research priority is something that we refer to as field-wide challenges. And that's where we have a specific concentration on why we cannot fulfill the goal of the first 2 targets. So what's helping, what's withholding us from curing the disease? Why are some of these symptomatic treatments being held up? And, some are very big challenges, and some are challenges that might be a little bit more approachable, like clinical trial recruitment, which Debbie touched on, or biomarkers, research tools that might be necessary or make it more efficient to study. So let's take a deeper dive into these 3 research priorities. The first one that I discussed, the disease modification portfolio, that's how we can slow, stop, or possibly even reverse the progression of Parkinson's disease. So let's look at some of the ways that we are trying to do that. I know that's, for some of you, like the meat of what's happening here. All right, so who here has heard the term alpha-synuclein? Anybody? All right, we have a few. Who here has heard of dopamine?
Hello.
All right, every hand went up at that one. So forgive me, I'm just going to take a few minutes to discuss alpha-synuclein, if that's okay. So we all know that Parkinson's is caused by a depletion of dopamine in the brain. But have we ever stopped to think, like, why? What's going on here? Why is there this depletion of dopamine? What's happening? So, for a lot of people, there's a cause. And the cause is because there's something in the environment of the substantia nigra, which is where the dopamine lives, that's causing toxicity. And that's what's killing off the dopamine. Or as I recently heard, there's a new theory that perhaps the dopamine's not dying, that it's like in a state of senescence, which is like a rest period where it's sort of turned off, which leads to the same symptomatic sort of progression that we see anyway. So whichever one it is, what so what's happening here? So I'm going to talk a little bit about how we discovered alpha-synuclein, but I'll just kind of discuss what it is. What we found is that there is a misfolding protein, and this is something that you'll see in a lot of neurodegeneration, that there's a protein that acts up and it misfolds, and that is what causes this toxic environment for dopamine. Once the dopamine's been compromised, that then leads to the symptoms that we see that manifests the Parkinson's disease. Sometimes when I describe it, I use what I like to call the fishbowl analogy. So say you have a fishbowl and you fill it with lots of beautiful goldfish and they're swimming around, and one day you notice that there's a little goldfish floating at the top, so you scoop it out and you go about your day. What happens the next day when you notice there's a couple more? Like, hopefully you get rid of them before the kids see, or whatever it might be. Well, you can keep going to the pet store and replacing these goldfish, but maybe it's not the goldfish. Maybe there's something wrong inside the fish tank. Maybe you need to clean out those rocks. Maybe there's something in the water you're putting in. So when we take medications for Parkinson's disease, we're taking this levodopa-carbidopa usually, and we're replacing those goldfish, those dopamine neurons that have been compromised. But what we're trying to do is clean the water. We're trying to clean the environment around the goldfish and seeing if that will help it thrive. That's the way we look at alpha-synuclein. Alpha-synuclein is a protein that misfolds and it causes the toxic environment for dopamine. So we've decided, instead of concentrating so much on the dopamine, let's clean up the environment around the dopamine. So this is exciting for us because this would lead to a cure. These dopamine clumps, these alpha-synuclein clumps, they're sometimes referred to as Lewy bodies. So that might be a term that you've heard. Not to be confused with Lewy body dementia. This is like a completely different part of the brain, but they're pretty much comprised of the same things. About 90% of a Lewy body is comprised of this misfolded alpha-synuclein. So when we figured this out, which wasn't something that we knew of until about a handful of years ago, we realized we have such a promising target for a cure, for a therapy. And there was nothing in clinical trials at that time, but we really put an emphasis on this because we found it to be a very promising lead. And if you look on this board, you'll actually see 10 alpha-synuclein trials, clinical trials, meaning it's being tested in humans right now. And I just want to discuss a couple of different ways that we are approaching this issue of the clumping alpha-synuclein. So if you look at the one at the top, Epheris, which is in phase 2, it's taking a vaccine approach. And that means it's kind of like the flu. They're injecting a little bit of this alpha-synuclein and they're trying to retrain your system to fight against it. So maybe they'll be able to self-correct. We also see there's an antibody approach, which is a way of using your body's own antibody systems to try and clear these alpha-synuclein clumps. And you'll also see a number of trials using the small molecule approach. And sometimes I like to refer to the small molecule approach as kind of like a Drano approach, when you have a clog in your sink and you pour in the Drano. So we're trying to blast up those little clumps in that way. And each one of these trials, even if they're using the same methodology, they're doing things a little bit differently. So it's not like 10 different trials doing the same thing. This is 10 different shots on goal. And there's actually insider news. I think there's definitely about to be an 11th and possibly a 12th trial also testing ways to really fight this alpha-synuclein. But when I see that these things are in clinical trials, I know we're going to get results, and they might be positive or they might inform a trial in the future. But that's going to happen within 5 or 6 years. That's within sight, you know. I think often we think of a cure as like a pie in the sky, and I really hope out of all things this sort of gives you like that sense of hope. There are so many people working towards something that would really um, tackle the disease at its root on so many different levels.
That's why it's so important to stay healthy, do lots of exercise, so when the cure happens, you'll be able to take advantage of it.
Exactly.
That's what we're here for.
Exactly. Very true. Great, right? We have to make sure that we're tip top shape for when it happens. Um, so this is one way that we're looking for a cure is through our alpha-synuclein portfolio. Another way that we are looking for a cure is something that I think you're all familiar with, because I think it's kind of the Ashkenazi Jewish population is sort of a little bit more susceptible in this area, and that is our exploration of genetics. So oftentimes, the foundation puts quite a lot of money into genetics. In fact, our largest donor is a carrier of the LRRK2, the LRRK2 gene, and he actually does have Parkinson's in his family. And so we are putting millions and millions of dollars a year just into LRRK2 and into GBA. And very often people will ask me, you're studying genes so much, but how will that help people who are not genetic carriers? And most people with Parkinson's, to the best of our knowledge today, don't carry a genetic mutation for Parkinson's disease. In fact, it's only about 10% of people with Parkinson's that have a known genetic link to Parkinson's. Most people have what we call idiopathic Parkinson's, but we still spend a lot of time and money studying the genetics of Parkinson's. So sometimes I'll get asked why, right? Doesn't make sense. Why? Thank you. I'm like, no one's asking. Thank you for stepping up. Okay. So the reason is because when we're looking at the disease, it kind of helps to have a pathway. And I use a lot of analogies, so forgive me, but I think that they help. I compare looking at someone's genes to looking at a recipe card, or looking up a recipe in a cookbook. And if you're making a cake and it doesn't turn out, sometimes you turn back to the recipe and you're like, oh no, I forgot the eggs, or oh no, I put in an extra cup of flour, and it explains it all. Now, how can we do that with Parkinson's disease? Well, some people are unfamiliar with ruining a recipe. I'm very familiar with it. So with Parkinson's disease, what we can do is we can try and look at the recipe card. So somebody with a genetic mutation that we're able to identify, we can see how is that gene working differently than it is in people who don't have that same genetic propensity, right? And we can see, with LRRK2, maybe there's like an overexpression as compared to people who don't have that genetic mutation. With GBA, it could be the opposite. But that gives us kind of a clue into what's happening that might give people, more of a susceptibility to getting Parkinson's disease one day. And we can work out a therapeutic using that information that we haven't thought of before. And that therapeutic won't just apply to people who have that genetic mutation, it would apply to everyone. And I actually have an example of a time that happened in Parkinson's disease. So we talked about alpha-synuclein a couple minutes ago. So how did we discover alpha-synuclein? So synuclein is a protein, the way that we discussed it before, but it's also a gene. And there is one family in Europe that every single member of that family, when they would hit a certain age, they would develop Parkinson's disease. And that has not been seen anyplace else, that every single member of a family would develop Parkinson's disease. So we did just what I described. We looked at their genes, we looked at their DNA, and we were able to discover that on their synuclein gene, they had a mutation, and that is what caused every single member in that family to develop Parkinson's disease. What we realized when we looked at the synuclein gene was this wasn't just happening in this one family that had the mutation, but we were finding clumps of alpha-synuclein in autopsy tissue of people with Parkinson's almost across the board. And I think that that's a very good example of how studying genetics can really be applicable to everyone as a whole, because we were able to identify a target that would help everyone, but we were only able to really narrow it down by looking at this genetic information. So that's very often what we're trying to do in our genetic portfolio. So far, I've heard about 80 genetic regions for Parkinson's disease, and that's kind of an explosion. 10 years ago, we only knew of really just a handful, about 10 different mutations that would lead to Parkinson's disease. So we've really come a long way, and I've been hearing that we've been discovering more and more markers on some of these genes than we've had ever before. So there's quite a lot of ways that we can look at things and maybe give people some preventative measures if we can't stop it. So there's so much information that we can use. And I just want to walk you through how genetic discoveries can really help everyone, not just people who are carriers of a genetic mutation. So the way that we do it is we'll locate a gene, we'll find a family, much like the one that I was telling you about that carried the synuclein mutation. And we all know that these two genes that I've mentioned, the LRRK2 and the GBA, they seem to have a higher propensity of being in the Ashkenazi Jewish community. So we'll locate a family. In our case, this country, we're sort of all family in some way. And we'll examine large populations, which is a lot of the work that I saw happening in Tel Aviv this week, and a lot of other clinical trials will come here because we have a very large population in Israel of people who are carriers of these genetic mutations. We'll try and link the gene to the biology. We'll try and see how that gene is acting in a way that might be unusual, that could give us clues. So how do these mutations impact protein function? Do people without the mutation, does their same gene act in the same way? We'll use those comparisons to develop treatments. And we'll try and see how that can really affect the wider population of people with Parkinson's who have what I called idiopathic Parkinson's. Okay. So our next research priority is our symptomatic portfolio. And that's really where we'll explore better treatments for the symptoms of Parkinson's disease. And often when I discuss the symptoms of Parkinson's disease, excuse me, we know that there are so many symptoms beyond the tremor. I feel like the tremor kind of got a name for itself as like the symptom. But what I've done here is I've outlined a number, but not all, of some other symptoms that people with Parkinson's disease may exhibit. I'll hear a lot of people with sleep problems, or maybe some cognitive issues that they didn't have before, and they always ask me, what's Parkinson's? What's aging? I'm not sure what's what, and it can be very confusing. A lot of people will exhibit smell loss many years before they have another symptom that shows itself within Parkinson's disease. Mood changes, digestion changes, and it's not just about the tremor. Gait and balance seems to be a big one, and definitely exercise and doing a lot of these different activities here at Type for Parkinson's would definitely help with things like that. But there's a lot that we need to address that's really affecting the lives of people with Parkinson's disease. So the first thing I wanted to talk about was drugs. Generally, there is a drug that most people with Parkinson's take. I don't know what it's called here. Is it Cinemet here? Also Cinemet?
Few things.
Okay. It's the levodopa-carbidopa, which replaces... Okay. All right. Thank you. So that's the levodopa-carbidopa that people take to replace the dopamine loss, right? But in America, we actually have a slew of other types of treatments that we have. So I just thought that I would mention them because we actually noticed in the past 5 years there's been a huge uptick in drug approvals, and also not just drug approvals, but I've also added some like technology that's been coming down the pipeline too that people use for treatment of their Parkinson's. And so I wanted to discuss those because it seems like the past 5 years there's been more than there's ever been before. Has anybody ever heard of some of these? No, we can't see them. Okay, I'll be able to see. What?
These are the agonists.
Yeah, some of them. Some of them are, some of them aren't. But I'll tell you one theme that I've seen here that I find interesting. So what we found is that the chemistry of this drug, of the levodopa-carbidopa, which apparently, like levodopa, that's been the drug for Parkinson's for like the past 60 years. Like the treatments have not changed. And across the board, everybody agrees that the chemistry of that drug is really perfect. It really does mimic dopamine in your brain. The issue comes with how the drug is administered. Very often people will have peaks and valleys in their day, right? We call those on and off periods, where you're kind of like riding that roller coaster up and down. And I'll speak to a lot of people who will discuss how they sometimes feel anxiety because they could be outside trying to live their lives and they'll freeze. And that's because there's been, an off period within their medication. So just managing how the medication gets to where it needs to get becomes challenging. And there's a lot that goes into medication, We're trying to treat the brain, so we're taking a pill and it's going through our digestive system and it's interacting with our food, and maybe if we eat something at a certain time it's not acting the same way as it did yesterday, and then it has to travel across the blood-brain barrier, find the right place in our brain. There's a lot going on in order to get the medication to where it needs to go. So we've had a lot of concentration on taking the chemistry, which we believe to be correct, it seems to be, and finding different ways to administer it so that it gets to where it needs to go quicker and more efficiently. So we were talking about drug development before, and there's one, probably the most recently approved drug that we've had is this last one called Inbrija. I'm not sure if that's something that you have here. It's like an inhaled form of levodopa.
No.
Okay, so maybe look out for it because it will probably be coming soon.
What is
and what that is, it's called Inbrija. It's this last one over here.
I think the trials were done here.
I think some of them were too.
We do not have a drug in the market today.
Okay. So this is something that maybe you can look forward to coming down the pipeline here. It's only been available for a few months, just under a year now in America. It was approved, I think, late last year, but it didn't come on the market until a few months later, so probably early 2019. And what that is it's a project that the Michal Fox Foundation was involved in from the beginning, not just with money, but also in terms of like input and trial design. And it's what we call a rescue therapy, which means that, do you know inhalers like for asthma? So this is something you can carry in your pocket. It's like an inhaler, and when you feel an off period or you've frozen, it's a way that you can inhale a quick dose of levodopa-carbidopa. And you don't have to digest it. It is absorbed through the membranes in your cheeks, and it gets to where it needs to be in about 10 minutes. So you get a dose of the medication much more quickly. Yes.
Like I was told to put the medicine like
under your tongue.
under my tongue.
Yeah, that's actually, so that's funny because so we actually have a supplement that's right now with FDA approval. It has not been approved yet, but it's an apomorphine strip, which is pretty much doing what you were told to do. I don't know if they have these here, but they're like breath strips, like a Listerine strip, where you put it in your mouth and it sort of just melts onto your tongue. Okay. Well, they're trying to come up with a formulation of levodopa-carbidopa that would act in the same way. Except you would put it under your tongue and it would melt through, which it seems like it seems like somebody told you to do that with your pills.
It does work.
It does work more quickly. Yeah. So you just do it with the cinnamon. That's really interesting. I mean, I feel like so much of when I speak to people are kind of like their behavior modification or like a hack that they've learned. So I like that one. Maybe I'll tell some other people to do that. But that's actually what they're coming up with as a formulation for levodopa-carbidopa coming down the pipeline.
If I'm drinking it, if I take it with soda water instead of water, they say it also goes to the so much faster.
Oh, okay. I like these tips. I meet with so many people who have issues with their medication digesting. So, anyway, thank you, Debbie. Thank you. No, not at all. But these kinds of tricks and tips are really great because it can make a difference in your medication management. What we're always looking for throughout the day with the medication is to get what we call the low and slow. So you have like the same amount of the medication throughout the day. So what happens when you get too much of the medication is you'll have side effects. Some people get dyskinesias, which is kind of like the rounded movements. Because they have a little bit too much of the levodopa in their system. And then some people will kind of slow to a halt when they have too little of it. But hopefully, if those are issues for you, those are things that you can talk to your doctor about, and maybe your doctor, like Debbie's, will give you some good tips. That certainly sounds good. I know people who are always like messing around with different times. But even some other things that are available, there are some people who have issues with muscles around their mouth, which might lead to drooling. So there are some new Parkinson's-specific Botox injections that you can have to that seems to curb that. We have a couple of different deep brain stimulation systems, and I've been seeing, I'm not sure if it was big here, but a bunch of people were sending me in America articles to the focused ultrasound, which is also...
That's in Haifa.
It's in Haifa? Okay. So yeah, it seems like a lot of people are using that because with deep brain stimulation, this seems to be less invasive and you have less downtime than you would with a traditional brain surgery. The issue with a focused ultrasound, as we see it, is it actually is kind of like, for lack of a better word, boring a hole into the brain. So with deep brain stimulation, usually that's programmable and reversible, even though it is more invasive. But focused ultrasound, there's a lot of hype around the results, but at the end of the day, it's not reversible once you get something like that.
This sign is only on one side.
It's only on one side?
It only works for the lung, it doesn't work for anything else.
Right, yeah, so deep brain stimulation also, I should point that out. We were discussing all of the symptoms of Parkinson's disease. It's really for motor symptoms, it's really for tremor. The other symptoms that come along with progression, it doesn't seem to have much of an effect on those. But, for some people, I find that a lot of people who are diagnosed young onset, those are things that they really like to look into because maybe they feel the tremor is, a lot for them to deal with. But I just think it's good to be informed on a lot of the things that have kind of come down the pipeline in the past 5 years. It's always interesting. Now, another one of these Another one of the symptoms that I discussed before was gait imbalance. Now, the Michael J. Fox Foundation, we generally will give support to other people who conduct research, but we actually have 2 clinical trials that we support. One of them is an online clinical trial, which I'll tell you more about later, called Fox Insight. It sends out surveys, and so it's all self-reported data. And we get a lot of our information and we'll decide our focus a lot on what people self-report. Now, we administered one of our surveys and we found that well over 60 people with Parkinson's disease self-reported issues of gait and balance. And this was very concerning to us because it was an immediate health risk, and it's also not something that we could develop a drug for. And even if we could, 10 years down the pipeline, it's an immediate risk now. There's a safety concern of falling. So what we decided to do was earmark $1 million for proposals that would have to do with tech devices for gait and balance. And we stipulated that we needed things that could be on the market within 1 to 2 years, because when it comes to gait imbalance and issues of falling, we didn't want to have people wait. It's something that is a concern right now. We ended up spending $3 million on that portfolio because we got so many amazing applications and so many great ideas that we decided to spend even more money than we had planned to on it. And I chose a couple of my favorites, and I'm going to share those with you now. And these are things that hopefully will be coming to market in good enough time for us to be using them and utilizing them in our lives, and also tell you why I like some of these ideas. So the first one, that picture that you see, that is the prototype of vibrating socks. Now, vibrating socks, I know, right? Mm-hmm. So these socks contain a sensor in them, and that sensor will measure your gait. So it will measure what is considered a regular step for you. And the sensor will notify you when your gait has changed. When you start shuffling or your gait changes, you're putting yourself at risk for falling. So what it does is it sends you a vibration, and that is just a cue to you. I have to widen my step. You don't notice when you start to shuffle. So this is just like a little cue, and I like it because you put on these socks and nobody knows you're wearing them. It's a pair of socks. And nobody knows that you just got a little vibration and you're gonna widen your gait right now. I just like how it's kind of like an incognito thing that you can do for yourself, but it really could help.
Will it cause problems in the airport?
Oh, that's an excellent question. maybe keep it in your carry-on. I don't know, but I'll ask. Right, we have to worry about everything. The second one I also really like. It's a belt, and we actually spoke to them that it looks a little bulky. We're trying to make it a little bit sleeker, but it's still something that you could fit underneath your sweater or your shirt, under a pair of trousers. And what it does is it uses airbag technology, kind of like the technology that you would have in your car, and it notices when you start to lean to one side or the other, and it inflates just a little bit to correct your posture.
And where is it?
It's what? You wear it underneath your clothes, around your waist. Around your waist. It inflates just a little bit, and then it can sense, it has sensors in it, it can sense if you're falling, and then it deploys like a safety device, like a little ring around your waist, and you look ridiculous for a few minutes, but you know what, you didn't break your hip, so that's good. But it's like a safety measure, and I like it because it can be pretty incognito. You can just put it on underneath, but you know that you're doing something that will help you with your personal safety if you have an issue with gait imbalance. I mean, it's around your trunk. I would suggest.
Fall in the shower.
Oh, that's interesting. Yeah. So I mean, I'm sure it would. There's no like gadgets or different things, but that's a very good question that I can certainly pass on. What? You can make it into right. You can make it into a raft. Hopefully you won't need it. But that's a good question. Remind me to answer you via email. Get my card before you leave. The last one, I just kind of like it because it reminded me of a robot. I don't think it's for anybody here, but it's actually made by the Honda company, and it's an exoskeleton, and you can use it to help you on days when maybe you can't get physical therapy, or if you wanted some extra physical therapy at home, you could put it on, and it really helps you with your walking and improving your gait. So it's sort of like a practice device. I just gave you 3 of the ideas that we had, but we also funded like canes with lasers on them. Those are very helpful, and I actually found it interesting as to why, so I'll just share that with you. Some people find when they're walking, they start to shuffle or they freeze, and they can't walk anymore. But if you put something down in front of them, they can step over it. And that's because there's a different part of your brain that's used for walking than stepping over something. So this cane with a laser, once you see a laser beam in front of you, it can prompt you out of a freezing time and you can walk over it. So we had, what? Yeah. So we have like a number of devices. If anybody's more interested in looking at this information is readily available on our website. And again, I can give you my card, so if you ever wanted a link in the right direction, you can let me know. But this is another area where we are approaching our symptomatic portfolio. Now, very often, people will ask me, well, what else can I do? I can take drugs. This is kind of interesting with the gait and balance portfolio, but what else can I do to manage my symptoms? And of course, we're at TICFA for Parkinson's, so we can really say out loud, the number one, anecdotally, across the board, the number one thing that I hear is that exercise is medicine.
Yes.
And that exercise is the best thing you can do. So then what people will say to me is, what's the best exercise for Parkinson's? And our line is, the one you do. Thank you. Exactly. Whatever you do is the right exercise. So there's no right exercise. It's whatever you'll do. I have found anecdotally some people who do yoga or boxing will discuss increased flexibility. I know a lot of people do things like ping pong, and it seems like things with hand-to-eye coordination certainly seem to help people's symptoms. But again, whatever you'll do. Cycling seems to be very popular. I was telling Debbie that people say to me, I don't have Parkinson's when I'm on a bike, or I don't have Parkinson's when I'm dancing. But walking down the street, they have Parkinson's. So exercise is certainly going to be helpful with that. We have also found anecdotally that people who practice mindfulness or meditation, that certainly helps with moods or other symptoms that have to do with Parkinson's. And we've also found that there seems to be, at least after diagnosis for a while, people are reticent to get involved with social activity. And being involved socially at groups like this, at support groups with your family, with your friends, has certainly seemed to have at least mental health benefits and probably some other benefits also with Parkinson's symptoms. Another one of the questions that I'm asked very often is about diet. And for people who really want to get into diet, the Michal J. Fox Foundation has actually released a diet guide. We don't have any concrete evidence about diet, and the reason for the fact that I can't specifically tell you more about one diet or one exercise over another is because it's very difficult to test that kind of information in a clinical trial. Like, how do we tell somebody, you eat, a really balanced Mediterranean diet and you eat junk food and we'll see who's doing better at the end of the day. So measuring these kinds of things, it really has to be anecdotal. So I mentioned Fox Insight, our online clinical trial earlier. So what we've done is we've taken that data set and we've taken certain other data sets from other information sources, and we've earmarked some money for epidemiological studies. And what that means is that we'll study these data sets. It's all self-reported. It's using the same information that informed our gait and balance portfolio. And we'll try and see if we can make any links to certain diets that seem to be helping people's symptoms more than others, or maybe certain types of exercise that seem to be helping people's symptoms more than others. But that sort of data is all coming through these self-reported mechanisms. So we do know, yeah.
What about diagnosis?
Oh, I'm going to get to diagnosis soon. Sorry, it's coming up. So yeah, so we do know in general, for everybody, Parkinson's or not Parkinson's, eating a healthy, balanced diet is key. Try and get in antioxidants. That certainly seems to be great for neuroprotective qualities. And maybe try and make some adjustments with your medication, because sometimes I do find that people seem to feel like their medication works differently when they eat certain things. So maybe paying attention to that might be helpful if you're looking very closely at your medication regimen. Okay. So now we are at our final research priority that we'll discuss today, and that is field-wide challenges. So what's keeping us from finding a cure? What's keeping us from any sort of symptomatic breakthroughs? So we just had a question about diagnosis, which is like really a wonderful segue here. Right now, and I hear this all the time, especially in America, right now you get diagnosed by going to your doctor, and if you tick off a couple of marks for having some of the symptoms of Parkinson's disease, you have your diagnosis, and doctors will become experts to the point where some of them feel like they can look at somebody and diagnose them, but of course they take them through the ringer. And when you go to your Parkinson's appointments, it's much like some of your diagnosis initial appointment, right? You're walking up and down a hallway, you're doing little hand exercises. Yeah, exactly. You're pulling things, you're pushing things, you know. And that has been the way diagnosis has been for the past 60 years. And it's still the way we do things. And it seems to be the most effective form of diagnosis. Now, why is that? There's no test that you can take that tells you whether or not you have Parkinson's disease. And that's because we lack something called a biomarker. And a biomarker is a biological characteristic that alerts us to risk, onset, or progression of disease. I'll just give you some examples of biomarkers, right? You test your blood sugar and it tells you whether or not you have diabetes. You take a test, you know, right? Cholesterol will tell you about heart disease. You take a test, you know. There's nothing like that for Parkinson's disease. They recently came up with something called a DAT scan, and that measures the dopamine in your brain. But we know that there are certain people who have dopamine depletion or will measure on a DAT scan, and they could have like a Parkinsonism. Doesn't necessarily mean that they have Parkinson's disease, so it's not conclusive. It's a clue. It could be like another clue into your diagnosis, but that alone generally will either confirm or deny the diagnosis. Yeah.
My husband recently sent me an article to do
Yeah.
About a blood test for Parkinson's, which is in like stage 2 clinical trial.
Yeah.
And I
In Israel.
And I sent it back to Dr. Archimedes. I said, do you know anything about it?
Yeah.
And he said, I wrote it. This is my file.
Oh, wow.
Our Dr. Archimedes is very humble.
That's amazing. Yeah. And there are so there's the blood test that's in clinical trials right now, and there are a couple of other ways that we are looking to find a biomarker, and that is a big challenge for us. And it's something that really affects the Parkinson's community in ways that we might not think of. Like, for instance, say somebody is misdiagnosed with Parkinson's disease. and then they participate in a clinical trial for Parkinson's disease, and they could really sully some of the results of that clinical trial because they don't really have Parkinson's disease. It was misdiagnosis. So finding a biomarker could help in a myriad of ways. If you're running a clinical trial, you have to conduct all of these tests to see if it's working. How wonderful would it be if we had a biomarker, like we could give you a blood test and we can be like, the Parkinson's is receding, the Parkinson's is stopping. Now it's really trial and error. We have to see, are you progressing or are you not progressing? Let's wait and see if this is working. And so finding a biomarker is a phenomenal field-wide challenge for us. So that is something that we concentrate on a lot. So I mentioned some of the different tools that finding a biomarker would help with, like early diagnosis or diagnosis period, charting disease progression, designing clinical trials, and testing the impact of new therapies. So with this in mind, in 2010, the Michael J. Fox Foundation launched, I mentioned Fox Insight. This is the second clinical trial. It's half sponsored by the Michael J. Fox Foundation and it's half sponsored by industry because they would also like to find a biomarker. It would certainly help them be more efficient in drug design or any sort of new treatments. And so we launched the Parkinson's Progression Markers Initiative, PPMI. I've definitely met some people who are part of PPMI, maybe some even in this room who are part of PPMI. And we have 33 clinical sites around the country, including in Israel. Around the world. Yes, thank you for that correction. Around the world, including in Israel. And it's a longitudinal study where we follow a couple thousand people who have Parkinson's disease and controls. So people who either have a marker for Parkinson's disease, a genetic marker, or people who are just controls, so we can compare the data. And we try and measure any kind of way that we can. And Debbie was mentioning the spinal tap. I jokingly say we collect the blood, sweat, and tears of people with Parkinson's disease, but we actually kind of do that. So we're collecting a number of different kinds of scans and tissue so that we can find some way anyway, be it a blood test, maybe it's watching somebody's gait, maybe there's a sample in smell. I heard recently that there was a super smeller who says that she was able to smell people who had Parkinson's disease before they were diagnosed. So there are a number of different ways that we could go about finding a biomarker that we could then develop into tests. And so using the Parkinson's Progression Markers Initiative, and I added including Israel in there, we can find a way to come up with a more conclusive diagnosis or come up with something that across the board we'd be able to test. Yeah?
Is Israel Hospital the only location where you're doing research under your foundation?
No, not at all. There's a lot. So there are places really all over the world. It's like we have over.
I meant in Israel.
Oh, in Israel. So for PPMI, yes. I know that we sponsor research that's not just in Iqlab. I don't off the top of my head know where, but for PPMI, that's our only clinical trial site here.
The only place to do clinical trials is in Israel Hospital. They choose one.
There's one trial. Iqlab Hospital does like many clinical trials. They also are participants in this one in particular. We are funding part of that, but we also do actually have other places in Israel where we are funding research. It's just not in what I'm talking about right now.
Clinical trials, then what type of research would that be?
I have a list of it and I can talk to you about it afterwards because I just don't know off the top of my head. Sorry. But yeah, get back to me. So here I just wanted to give you like a little pictorial of the different ways that we follow participants in PPMI. So what I discussed was we measure body fluid and tissues. So we'll take those kinds of samples, and there are certainly some people who are kind enough to go through a spinal tap essentially, and provide us with cerebral spinal fluid, and we are forever grateful for them because that is not comfortable. But we also take images of the brain so we can see if there are any patterns that we could identify there. And in addition to that, we have technological devices that we have people wear because, maybe there's like some sort of pattern that we would be able to chart in, I don't know, like heartbeat or gait or whatever else we're looking for. So we're really trying to explore all of the different ways that we can find a biomarker. All right. Now, it's a lot of information that we've gone through, and we talked about actions all the way in the beginning. So oftentimes people will say, okay, well, what can I do today? And even if you weren't thinking it, I'm going to bring it up.
Can I just ask one more question?
Yeah, sure. Yeah.
They talk about people being the guinea pigs for new medicine, but I know in Israel personally they're not dispensing any medication, and they specifically say to all the people in the research, they actually don't identify them by name or just by number, and they say your participation in our research program won't directly affect you, it will be for the next generation.
Yeah.
How accurate is that?
So yeah, so it depends with what. With PPMI, that sounds exactly like our study. I know that they administer other clinical trials, but maybe somebody wouldn't be a participant in those. But for PPMI, we do not administer any medications with it. It is really just kind of like to watch, to observe, and to collect. And that is for future generations because maybe we can, with some of these cohorts, there's people who don't have Parkinson's yet, or there's people who might have like a genetic disposition or be carriers of a genetic mutation that might give them a higher chance of developing Parkinson's in the future. And we don't administer any sort of treatment. We're just sort of looking at them for the future because maybe we can find a way to diagnose earlier or find a way to prevent things or see certain patterns of development. So it's really kind of an observational study.
So just let me add, I was a participant
Oh, thank you.
No, the reason why I'm asking questions is well, it was an incentive for me since going all the way to Israel, it's not around the
Not
corner.
here, yeah.
They had said we develop a pill to slow down the progression or cure depression, however they worded it. The people in the research program will be the first ones to have it, and now you're saying exactly the opposite. And they don't dispense it, so that's how they're attracting people to participate.
No. Sorry, then I didn't understand your question.
No, I was very clear.
No, I didn't understand. I'm sure you were being clear. What I'm saying is we don't dispense it now because we don't have the data for it. When we develop drugs, if that's a deal that they've made with their clinical trial participants, then yes, of course, like I would trust them. I don't think that they're tricking or misleading anybody. All I'm saying is that the study that we are funding is an observational study. It could be that part of the incentive for people doing it is because they'll be first on the list when there's drug development. But in terms of these things contradicting each other, I don't think that they do. Okay? I'm just saying there's no. At the same time, they have 7 other trials that do have drug development. You might not be part of those trials, but perhaps you'll be, shortlisted for those. I saw quite a few of them. Yeah, I took a tour earlier this year. Yes, I saw them. Okay, and some of them are using certain things that I was mentioning before when I was talking about alpha-synuclein. So let's talk about this later because I'd love to tell you the specifics of it, but I also just want to finish here. Okay?
You'll be meeting with people privately upstairs.
Yeah, I'm happy to meet with anybody privately afterwards. Okay, so what can you do today? Well, I'm going to make my pitch now. I have quietly been mentioning Fox Insight, so I'll start there. And this is something that anybody could join. It's from all over the world. Right now, I believe it's only in English, but you sign up online and we deploy surveys quarterly, which means that every 3 months you can spend, it won't take you more than 45 minutes, but you just answer some questions and it goes into a very large database that we have where we decide things like what we're going
And
to
it
fund.
takes actually much less
I think
after
so.
you've done it one time
Yeah.
because you just, if things have not changed, then you don't have to reinstate.
Right.
I
And
think
it's all
that's what I'm
online,
doing
right?
Yes,
also.
this is all online. Thank you for anyone who's already a participant. We have over 40,000 people with Parkinson's and controls who are part of this study, which makes it probably the biggest Parkinson's clinical study in history, and definitely in the world right now. So that's very exciting. And as with all of the Michael J. Fox Foundation grants that we support, internally also, all of this information is freely available for anybody who wants to access it. And this information has been downloaded many millions of times over, which is exciting because I only know about the research I know about, but maybe there's somebody else that I don't know about who's curing Parkinson's right now and is using this information in some way. So that's exciting. Debbie referred to this other tool before. It's called a Fox Trial Finder. And you can just go online to Fox Trial Finder, and we kind of call it, we joke that it's like the Match.com of clinical trials. You put in your information and you get matched with a clinical trial that you qualify to participate in your area. So you fill it out, and then you can look at all of the different clinical trials in your area. So if you want to participate in research, this is a really great way to find out about it. One thing I do want to say though about Fox Insight is sometimes they will talk to you about including your genetic data with it, and people who have Parkinson's, we actually in the United States, we send them a free genetic testing kit, which comes with genetic counseling. Unfortunately, that's not something available here, so if you see that when you go on, unfortunately, I do have to tell you that's not something that's available overseas, but if you're in America and that's something that you want to take advantage of, you can link it. You can either choose to see the results, or you can just send the results to science so that we would have the results because it would inform our data possibly a little bit more. And then the last way that you can speed research is by donating. Now, generally, I will ask people to donate to the Michael J. Fox Foundation, and that might be a great option for you if you happen to be in America. However, we are not set up to be tax deductible overseas. It's just not a business viable solution for us. So we are only tax deductible in America. But if you're looking for a place to give some of your charitable dollars within the sphere of Parkinson's research or just Parkinson's in general, like I can give a rousing endorsement to Debbie Shapiro and Tikva for Parkinson's. I think this is like a wonderful place if you have some of those dollars to give. Okay. Another thing, another actionable item that you could do today is staying educated. And I find that, there's so much hope and there's so much good stuff going on now. I work for an organization where we have 180 people that are just constantly, every day, living and breathing a cure for Parkinson's. And we're looking at what we can do. And I think staying informed on what we have to offer and what others have to offer is really important. So utilizing the Michael J. Fox Foundation website, you'll find we have webinars that are on demand. I love them too. Thank you, Debbie. And they're very informative on any subject you either thought of or you didn't think of but would like to get informed on. We have podcasts so you can listen on the go. And then we also have a very popular feature called Ask the MD, where we have a movement disorder specialist who discusses all different sorts of topics from, dealing with loved ones with Parkinson's, telling workplace that you have Parkinson's, to, all sorts of other clinical issues that you might have. So really take advantage of those tools that we have.
Go to CME.
I'm sorry?
Say CME credits available. What is CME?
Oh yeah, CME credits, that's for people who do continuing education, which I don't know if that's available to anybody in the room, but thank you. And thank you all in general. Thank you so much for having me here today. It's like speaking to my family, it's not often that I get to I mean, it's never that I've gotten to speak to a room full of people in Israel. So it's so nice that you have me. I'm happy to take any questions if you wanted to ask them now, or if you wanted to ask them privately. I'm going to be sticking around for a little while. I'm sorry?
Do you have any cards?
Yes, and I have cards to give out to everybody, so if you think of a question later, I am available via email, and please don't hesitate to reach out. If I don't know the answer to any question that you have, I do know the person that does, so happy to do that. And with that, I just wanted to end off.
Where are you based?
I'm based in New York. Here we go. Sorry, I'm just trying to do this.
I want to give a little bit about particularly Parkinson's.
Yeah, if that's okay.
If that's okay with you guys, you're all familiar, but I wanted to tell you about the retreat because it was incredible. All right. First of all, I'm passing out. We always ask people to give donations when we come here to lectures. So pass the buckets. Okay.
Here, do you want to take
Yes.
this?
Yeah, I guess, do I need it?
I'm not sure.
Okay.
I'm not sure if I did.
Pass the buckets.
Pass the bucket.
Stand over here.
Okay. How do I get to the stuff on the oh, there it is.
Yeah,
I want to
here,
just
I'm
how
not
do
sure
I
why
get
it's
it on
not
to go
showing.
on? I just want to tell you this retreat was something that all of us returned home on a high. We just got such peace. We had the last night that we were there in the hotel, we had kumsitz, and Karlbach guy came, and he was actually he's a Ger Chassid, but he's also Karlbach, whatever, and he was singing songs and telling stories and giving words of divrei chizuk. And one of the things that I hope that we can, if not, we'll just have to see it on the computer. But one of the things it doesn't show. You don't see it. Okay, we'll have to see it on the computer, I guess. Maybe I'll ask Ephraim to put it on that computer. Ephraim? Ephraim? So I just want to share with you that the last night we had a kumsitz and we were all sitting in a circle, and he was telling beautiful words of how we can find the koyach to manage from our own selves. And one of the ladies there said, everybody was talking about miracles and personal miracles that they had experienced. And one of the people said, I think the greatest miracle of all is that 30 people with Parkinson's have gotten together and they are finding their strength and their belief in God. And I think that it's just, I think all of us have something very, very special here, that we all are using our emunah to bring us through this disease. And I think this is what makes our organization so special, is we are looking for our emunah to get us through the disease. And I don't know if all of you are aware of what we're doing. Most of you come to our program, so you know we have 30 hours of programming a week. We have over 100 people coming to us each week. We have a new program which is psychodrama, which is amazing. We now have guitar lessons and recording lessons for women with Parkinson's. We are soon starting a ukulele class for men with Parkinson's, which is really cool. And what's so great about this is it's fine motor and your voice because you sing, and it's cognitive because you're learning a new language of music, and you're having fun. So what could be better? So we're just doing a lot of amazing things here. You're all aware of it. I never tell you. However, what you guys pay covers about 45%, less than 45% of the cost of running this place. So we really do need donations. I am going to America in January for a fundraising trip. Anybody can give me connections to people that I can speak with there, or places that could host me for a lecture. When I have a prepared lecture, it's a little bit better than this. This is just off the cusp. But I would really like to speak with your friends and tell them what we're doing and show them what we're doing. I will tell you that we recently had a internal seker and questionnaire of the people in our group. Close to 90% of the people who are participating say that they feel better and their disease is progressing slower as a result of what they're doing here. So I think that's huge. And, you know, you guys are aware, so I feel like I'm speaking to friends and not to a public that I have to like say something much more, whatever. But please help. And I would like to. I'll try to. How do we get this on here? Because it doesn't. Maybe I can show also my. I also have the. Is there any way I can get it to show, or not? That is the video, and I also thought I'd shoot a 3-minute thing. Okay, if you guys have time, and then we'll. Can you get it on, or if not, it's not showing. It's not showing.
No.
Okay. Ah, here it goes. Look
Okay,
at this.
there.
This is there any way to make it a little bigger? Do you guys see it?
Hard
This,
to see.
this is one of the guys in the group. He walks with a cane. Watch him go up this thing.
Okay.
Is it going? If not, then I'll send it out to you. He walks up the seesaw, and then the seesaw drops down, and he walks down the seesaw.
Whoa.
And this is somebody who has Parkinson's and who has very big difficulties walking.
No signal.
We all had, it was amazing. Okay, I guess it's not gonna, it has not been shared, but you should see this. Not at this point, but it's really, really amazing. You would not believe the things that the guys are doing on this retreat. They themselves were amazed. What?
Is there any chance of sending these?
I have to ask him if he gives me permission for that.
Okay,
But
thank
if
you.
not, then no signal. Is it Mamish Chaval?
Can you show this another time?
I can show it another time. Can we see it?
Sure.
What?
No signal.
No signal. Okay, you know what? It's fine. Is it maybe? Oh, here it goes.
There they are.
Here, we'll do it again. Watch it again.
Okay, let's start again.
There it goes. See it go up?
Wow.
Ken, look at this.
Whoa.
Could any of you guys do this? We're fine. Could you do it? I couldn't.
Wow.
You want to show? I want to show the other. I'm not saying it right. Okay. Very quickly. You'll press it. You'll do the. While I'm here, I'll show you the mitzvah that we won a prize for. So, it's a 3-minute mitzvah, so we'll do it very quickly. Okay, let's do the next one. Can you get to it? I'm sorry, Fayga. And if not, then can you get to it's on the thing. How do we get to it?
So we only saw one video on there. They're doing it as PDF.
It's a PDF or it's a
So I wasn't sure.
he said it was not it's a PDF or a PowerPoint. It should be a PowerPoint. No, forget it. That's not the right one. Forget it.
We don't have
No, we don't have it on here. Fine, no problem. Okay, that's it. And thank you very much. I'm sorry to take your time. Yeah, but isn't that wasn't that amazing?
Yes.
I mean, we came back from this. People came back from this retreat feeling that they had come, that they were family. Sadie, do you want to answer questions or?
Yeah. I'm just gonna go get some cards and then I'm gonna come back
Okay.
and question.
This is not the right one. This is Zandasana.
Babim Kenneth.
What? This is Zandasana. Okay, no, this is not the right. This is not what we.
No?
Yes.
I wanted to show
Do you want to go, Bubby?
the,
Do you want to go?
I think so.
This is very fast. Yes. I'll go.
Does anybody have any general questions they want to ask?
What's the time?
Yes. I'll give you my